This video is going to demonstrate how to use your calculator to solve a 3x3 system using matrices. And we're going to use the problem from the previous example. And the way that you do that is you press second matrix. You can see it says matrix right underneath the math key or above the x to the -1 key. And then the first thing we want to do is edit a matrix so that we can put in basically this matrix here. So I don't want it to be a 3x3 with 3 rows and 3 columns. I want it to be a 3x4. So first I want to change that to a 4. And then the values in the first row are 1, -2. You can just press enter and it will move across them in a logical fashion. Then it came down here. I already have a -1 there. And a 3. And then I want a 0 and -4. And 2, -5, 5, 17. So I want to change that matrix to row echelon form if I wanted to do what we did in this. So then I will press get out of this, second quit, and do back to second matrix, and I want to do matrix math this time. And these are all the different things I can do. So that REF is row echelon form. So I'm going to choose that, and it's asking me to pick which matrix. So I have to go back to second matrix again and then choose matrix A. So I'm going to press 1. And then it's going to give me the row echelon form of matrix A. So, gave me a different row echelon form. It does have zeros and ones here. But if you solved it, you would see that Z is 2 and x plus 5z is equal to 9, and so if you substituted in the 2 into that equation, you would end up getting the same solution. That's interesting. It doesn't give me the exact same reduced row echelon form of the system, but I mean, it doesn't give me the same row echelon form, but it will give me the same solution, unless I typed something wrong. But let's try, see if I can recover this here. Let's try the reduced row echelon form of reduced row echelon form of second matrix A, and see if we get the same solution to the system here. We have x equals 1, y equals -1, z equals 2, x equals 1, y equals -1, z equals 2. And I'm pretty sure if we took this and did back substitution, we would get that same problem. We could try it real fast here. If you take, we know here on this that z is equal to 2, and this says that x plus 5z is equal to 9. And if z is equal to 2, then that would be x plus 10 equals 9. So, I'm sorry, this is y. So y equals -1, which is what I would want it to be. And then here, if I use this matrix, I would get x equals 1, and it would work itself out. So anyway, I like if I was going to use a calculator to solve a system by matrices, I would definitely just use reduced row echelon form, because why use a calculator and then have to do back substitution to solve it? You may as well just use reduced row echelon form. So there you go, and thanks for watching. Oh, you might be wondering why it is that then you have to do any of this by hand. And it's just because you do. Sometimes you don't get to access a calculator to solve a system. It's nice to know how to check it, but you do have to, at least at this point, it is expected that you could solve a matrix by hand using these operations that we were working on. So learn it anyway, even though it's kind of a bummer that the calculator can do it for you. This way you know how the calculator is programmed.